So hi everybody and welcome back to C++ tutorial series for absolute beginners. This is video 209 and in this video I want to talk about the big O notation and the merge sort implementation I will do in the next video. And let's get started. Why I want to talk about the big O notation, which is this notation here on the Wikipedia site. The reason for that is you will see in many algorithms, so for example this merge sort, this bubble sort, which we already talked a little bit, and in many other ones too, all time this little box and or let's say this notation here with which starts most time with a big O, and this is the big O notation. And when we read here what this big O notation is, let's start with the first sentence only. It says here, big O notation is a mathematical notation that describes the limiting behavior of a function when the argument tends toward a particular value or infinity. What is the meaning of this sentence? And let's read here a little bit more. The first sentence here, because this is more important for us. It says here, in computer science, and programming belongs to computer science, big O notation is used to classify algorithms according to how their runtime or space requirement grow as the input size grow. And this is important for us because they are classifying algorithms. And when we go back here, merge sort is one algorithm, bubble sort is one algorithm, and this big O notation, which you can see here in the box, is just an indicator of a classification if this algorithm is good or bad. So as a programmer, we have only to understand, can I use this algorithm in my code or not? And this big O notation is just an indicator. It's not absolute accurate, but indicates how the runtime or the space time when it's also presented here. The problem is we as a programmer have to understand it. And when we go back to this big O notation and scroll a little bit down, and if you would read here on, you can see they are using here many math symbols because the big O notation is normally a mathematical notation, so it comes from math. But we as a programmer, we skip the whole math section here because this is only how this big O notation is calculated and analyzed and then so on. This is the job for mathematicians or analysts. For example, you can try to become an analyst as well if you learn this math things. But we as a programmer, we don't care. We want just use it. And what I mean with use it, when you read this big O notation here, you have just to decide good or bad, which means, do I use it in my code or not? For example, when I read now merge sort has a, let's say, average time here, this theta n log n, then I read here average performance of bubble sort. Here is this big O n potence 2. You have only understand this comparison. Is this good, or let's say which one is better? And this is it. If you can do this, then you can skip all the mathematical part. But it is not easy. We need a little bit background, right? And when we go back here to this big O notation, scroll down a little bit, then we have a list here. And here again, this notation is the presentation which we will get probably from this analyst and mathematician who calculated the runtime or the space of the algorithm. We have just to understand this, but the problem is, wait a minute, to understand this kind of stuff that looks again so very mathematical and complicated. Actually, some we have not understand all, but some of them. And the best part is, here is a picture. Instead of looking these numbers here, which are used in the picture, we can look here just this picture. So if you this picture and this number here, you can see this n log n and log n and 1 and n quadrat is again this presentation like before. This was the table, which looks a little bit confusing for non-mathematicians, but this picture looks very simple. And as a programmer, you have just to distinguish and understand what is good, what is bad. Let's go back to our example. Let's go back to our average performance. Here you see this n log n, right? And here average, you see n in cubic, right? Then you go to this list, and this list has lines here, and here on top we have n log 2n, for example, and an n cubic. So the red line is our, for example, our bubble sort for average performance, and this n log n is, for example, this it's not this O notation, it's another variation of our O notation, but similar to that one. And it says here n log n, so around this one here in this map. And depends on this info now, you have to decide. And as a programmer, you say, okay, n cubic is bad. For example, it goes here fast up, which means it scales to a very bad size. This one is better. It goes not so fast up here. And let me show you the best case. For example, this O1 here is the best case when we go here back to the picture, and this purple one here down, the one here is the best case, which means it goes not up at all, which means it's all time the same time. So it doesn't matter how many elements we go into, it is the time. So in other words, you as a programmer need just do this. You read this symbols here. You don't care about the calculation. You just compare this one with the other one and try to understand what this O notation means, which one is better. And then you go here and check this little picture. I think this is one of the best pictures for starters. And then you can see n is better than this one. One is the best here, and the worst here is this faculty here, and so on. And then you can decide. And I think that was all what I want to say for a starter, because of course if you want to understand this more in detail, you have to go into it a little bit more. But there is one more note which I want to show you, and that is that this big O notation and this numbers which you see here is not accurate. Accurate means here it is just a range description. Let's go here back to this description, and you can see here when we read perhaps this line here, it says here big O notation characterize function according to their growth rate. Right, have a different function with the same growth rate may be represented using in the same O notation, which with other words, it is just describing how they grow. Yes, how they behave, right? What let's make a more concrete example. Let's say we have here a linked list. Let me create here fast a linked list with 1 element, 2 element, and 3 elements. That was our exercise, by the way, or so. Let's make 4. And that was our array with linked list, right? And this big O notation here says what happens when this linked list here gets more elements. So with other words, when we add here more elements, let's say, okay, I add to this list 1 more element, 1 more element, 1 more element, 1 more element, and let's say I add even more. I start to add all these elements to this one list here. And this big O notation says then, okay, I show you how your program will behave. And this is this picture here, what I say here with this one. If it's n cubic, for example, this bubble sort, it behaves bad. If it's n log n, it's still bad, but better than this bubble sort. If it's n, it is better than all the other ones here. And if it's 1, for example, this purple one, it's perfect. This is the best case it is. And if you understand this as a basic entry, that's enough. With other words, when you see again notation like this one, don't worry about the mathematical calculation, which you can read here on this side. Just skip this, because like I said before, this is the job of the analyst and the mathematician. They learn this kind of stuff. You just care about this picture, and your job is as a programmer to decide which you want. But as I said before, in programming there is one catch, because the mathematicians, when they start to calculate or analyze, they work with this symbol here. You can see this one, this infinity. And in programming, actually, we as a programmer, we don't work with infinity. Infinity means the number is so big, it is not even a number, because it's infinity, right? And we are not working with infinity in programming. We have all time limited sources on hardware, which means we don't care about this infinity results. The problem is they are included in this notation, and that brings us to the point where it can be, and that's why I said it's not accurate what they are showing us, right? They are showing us just an indication how it will behave after a certain point. You can see in this case we have here two lines, a red and a blue one. At start, the red one, let's say it's bad, and the blue one, it's good, but only the start one here. You can see the start point here. One, it's at 1 here, the red one is bad, the blue one, but at 2 here it switched. Now it's the blue good, and here the red one is good. And here at a certain point you can see this called x0, there is no more switches, which means before this certain point there are switches. We don't know which one is really better, depends on whatever elements there are and how they behave. But after a certain point we can say it will behave like this, what we present here. So with other words, this x0 is very important, because this x0 is our representation of this one after a certain point, right? The problem with this certain point is, like I said before, they calculate infinity, and I don't know if we need infinity in our calculations. For example, let's say we are in the range, not here for x0, let's say we are here till 4, then this whole notation indicates something which we can't, let's say we can use as an indicator, but it's not really useful, because between this x0 and the start point it is changing. And here we as a programmer can do then one thing which is even better than what mathematicians do. We as a programmer can just implement the algorithm and just test it, right? We just implement bubble sort, implement merge sort, and then we run the algorithm in the worst case and in the best case and average case, and test it on our machines. Because like I said, mathematicians and analysts, they are working with infinity. This is not realistic on normal, I say normal hardware. We have limited resources and it will not work there, most time not. And the only way for us is to be sure we just test it on the special code. But again, we just take this as a guideline, so you will see this notation all time as a guideline, but in the end we have still tested. We make some test runs of these cases, if this is really bad, and then check out in your system if it runs really at this time or not. Okay, I think I will stop here, because this big O notation is very big and you can dive more into it, but in the end, like I said, it is just orientation. And if you know this one here, that's it. This little picture says all. You can just say, okay, the one is here, the other is here. I have to decide, for example, this both. I say this is better, I take this one. Or I have to decide between this blue one here, log n, and this n log n. Of course, this blue one is 10th absolute better. You can see it's almost near on constant time, so I would choose this one. This is your job as a programmer, just to choose the better one in the end. If you understand this as a basic entry, that's enough. But of course in future you will dive a little bit more into it, but not necessarily in mathematics, but how to understand this more accurate, and how are the cases, and what are this different symbols as well. So like I said, they use here sometimes other symbols, not just O. Sometimes we can see here they use this other symbol here. You see this omega and this theta and so on. But in this video I wanted just to give you a short introduction, because you will see all time this O notation and algorithms, and they just indicate yes, it is good or bad, just as an indicator, and you can take this, like I said, a guideline, but in the end I would still test it, because like I said before, they calculate this with the infinity case as well, and this is not really realistic in hardware. We have all time limited resources, so test it on your machine as well, I would say. And with that said, I stop here, and in the next video I implement this pseudocode, and then I will again try to refer this notation a little bit what it means n log n here. But this little picture here shows also this little demonstration here, animation here is also very nice, how this works and why it is so fast. But with that said, in the next video. So I stop here, and if you have any questions or any comments, like all time, write it in the comment section, and see you in the next video. Bye, good luck, and like all time, have fun and don't give up.